guys. So I will continue from this point now. So the first thing that I want to do, I want to share with you some files in case that you want to, like practice your coding. So let me share the file with you. Okay, yeah, I just sent an email. So if you want to see the files, so assuming that you can see my screen now. Okay. So what we're going to do now, so we are going to basically to execute some basic, some examples about regression and multiple linear regression, and also we want to apply some uh, classification models. So for the first model, or for the first example that we are gonna try to solve today, we are gonna what we call the dataset ice cream. So for this problem, what we want to do is to know how we can predict the ice cream consumption. So we have some data. This is basically the structure, or this is basically the data set that we have. Yeah, and we are gonna the data set in which we are gonna work today. So this is the structure that you may see in the file that I just emailed you. So what we're gonna do with that? So let's do some exercises. So the first thing that I gonna do is to, well, this is probably, it's not like right now it's not necessary because I don't have anything in my environment, in my R environment. But for example, just imagine that I don't know, I define some variable data, and I mentioned, and I said like data is an one-dimensional array. It's a vector. So what if I want to clean the environment without, like click on this? So there is a command that we can use, rmlist equals ls. In that way, we can actually clean the whole environment without pressing any button. So this will be like something very nice to do in case that you want to run your code. Sorry, in case that you want to run your code from the beginning. So now I'm sorry. So what I'm gonna do now is to set our working direction, our working directory. So I need to get what is our working directory, like this. So this is the folder that I'm using right now, in where I store my code and all the data set that we have for this session. So it's basically this one here, and I'm gonna set it as my working directory. So now let's call the data. So I'm gonna create a variable data, and I'm gonna store the data set that we have, the ice cream data set that we have. So for doing that, I also create a data frame with the function. Sorry, sorry for that. With the function as the with the function as that data attribute. And now inside that function, I'm gonna call a new function that is read that table, the name of the file. So this read table actually is a function that is similar to read CSV that I should actually show you guys. And I don't want to see the headers in that one. So if you don't want to see the headers, or if you don't want to, yes, if you don't want to consider the headers of the file, you can just type this false, right? Otherwise, it's going to, like, it's going to recognize, are going to identify the headers because the this option header is equal to true by default. Okay? So right now I have my data. So let's see. Let's see how is the structure of my data set. I'm gonna call data. And this is the structure. So what we don't need about this? We don't need the first column because the first column is just for, like for notation purposes. So it's just telling me what is the first row, what is the second row, and so on. So we don't need that column. So we can actually remove it. So if you want to do that, comma. So in this way, I'm gonna remove the first column. So let's see again what happened with data. So can you see that? We remove the first column. Right. So the next thing that we want to do is only to consider columns 1, 3, and 4. That's the one that we are going to use for our example. So if you want to use some specific columns of your data set, you can apply some of the functions that Hanish explained at the beginning of the session. So this is what I'm going to do. I'm going to create a vector with the numbers 1, 3, and 4, and they are going to be the ID for each one of the columns that we have in the data set. So those are only the columns that we need so far. And I'm gonna name them. So what I'm gonna do now is to create a function, or is to call the function called names to the data. And then we're gonna create the following names: const that will be for consistency. Then we have int, and finally we have temperature. Those are like the variables that those are the name of the variables that we want to consider for our model. So there's something that you can use. I mean, and also Hanish explained you that we can call the function attach. So with this function, we don't need to, call a specific column in the data set. So if I use the function attach, I can pull okay. It's going to create a plot. So if you see what I want to do. So with the plot function, I'm gonna call cons. That is one of the column name here. And just consumption. And Okay, so let's going to see our plot. Let me run this again. Okay, so not pretty sure why the function attach is not working. So let's do this. Sorry. Not sure works. Okay, so this is basically the plot that we have for the consumption versus the observation. This is the behavior that you can observe from this variable. So you attach is working, so everything's working. So if you don't use attach, you know, like we need to call the variable consumption in this way. But since we are using the function attach, we can avoid that. So let's going to create more plots. So we're gonna create a plot for all the variables that we have. So now I'm gonna create a plot for income, that is INC. So the color here is red for this one. And then we have the label for the x-axis, observation as well. The y label. Okay, so now you can see what is the behavior, what is the expected behavior of the, well, it's not the expected behavior, what is the behavior of the weekly family income variable that we are considering in the data set. So now let's going to create one more plot. This is for temperature. It's gonna call dark green. And I'm just gonna copy and paste this. Just to make it faster. And here for the y label, temper. So that is basically uh, the way or basic, that's the behavior of the three variables or G features that we are considering in our model, for the model that we are going to do. So you can also, if you want, you can also use R for, as Anisha mentioned, that R is actually really amazing for data visualization. So if you want to like build an histogram based on the data that you have, you can do that. So you can call the function hist, H-I-S-T, and we can do like the same thing. So I'm gonna call the variable counts. Then we have the columns. So the color, right? This is color sky blue. Consumption. And this is the histogram for this variable. And we can have an histogram from each one of the variables also. This is red. Okay. Dark green. So if you have any question, please let me know. I mean, you can raise your hands. Is there something that you want me to go over again? I can do that. So don't be shy. So now let's going to create some scatter plot. So for doing that, I'm gonna call the function core data. So with core data, you're basically going to see what is the correlation between all the variables in the model or in the data set, sorry, in our data set. So as you may notice, or as you may know, a good correlation, well, a good correlation relationship between two variables is when the values actually is not zero, right? So there's correlation. So when the correlation is equal to zero, that means that those variables, they are not correlated. So usually the correlation is a value that is between -1 and 1. And if the value is negative, because the correlation is negative, and if the value is positive, it's because the correlation is positive. So why we have 1 here? Because obviously they are the same variables, right? So the correlation between the consumption and the consumption is actually they are highly correlated. So because it's the same variable, and is the maximum correlation that is 1. Okay, so this is our correlation matrix. So now that we already know our data, let's going to create a simple linear regression. So I'm gonna call, or gonna create this variable regression 1 to storage to storage the model, the linear model that we are going to create. So I'm gonna call the function linear model, and I just wanna see the linear model and explain the relationship between the consumption and the temperature of the data set data. And after that, I also want to see a summary of that regression model. So now let's going to run it. Here we already generate the simple linear regression model. And this is the summary. So basically this is the way in which the residuals are distributed. So this is the minimal value for the residuals. This is the maximum value for the residual. Here you can see what is the median value. For coefficients, so this is like well, this table that you can see over here in the summary is something that is very common in some of the other software, statistical software. So for example, here we have the estimated value for the intersection, and we have the estimated value for the temperature. So those are, if you know about linear regression, you know, like when you are working with those kind of model, what you're trying to find is an estimation, is a mean value. Basically, that's what you want to do, is to find like an expected value, or what is like what is the intersection, and what is the coefficient of the of the slope, because, well, for the linear regression we may have like several coefficients that they are the what they show is the slope in just like if you have like a linear function. So this is the value of the coefficient of, of beta 1. This is the way that we usually call it. This is the standard error, and the other side we have the t-value. So what is the t-value? The t-value is an statistic, and we use this statistic for something that is called the model. Well, the model that we call the model utility test. That is an hypothesis test that actually allows us to identify if some variable or some feature could be relevant for our model or not, or should be significant. So R is actually telling us that, well, temperature is actually highly significant, as you may see over here, because this is like the code that they use for indicate that if some variable is significant or not. And the other thing that is telling us that this variable temperature is significant in the model is the p-value. So if the p-value is a value that is below, well, this is like an standard. I mean, that's depend of the way of people actually wants to formulate a hypothesis test, but if the value is below the 5%, we can consider that, well, the variable or the feature is relevant for the model. So that's something that it happened here. So this temperature actually is like, as we may see before, as we may see, is very important, is significant for the model. So this is the residual standard error. Here we have the R square, just R square. So you know, like R square is the coefficient of determination that actually tell us what is like what is the portion of the variation in the response variable that is actually explained by interaction, by the interaction with one of the control variables, that is in this case is the temperature. And then we have the F statistic. So if you want to find what is the S statistic, this one is estimated as the square of this one, of the t-value that you see here. So how you find the t-value? So basically you can actually make the test. So you can, if you want to estimate what is the t-value by hand, you only need to divide the estimated value of the slope over its standard error, and that's going to give you what is the, and that's going to give you the statistic, the t statistic of t-value that we have here. This value is also important because you can use it if you want, like like define a confidence interval that provides some range of values in which the slope may be, or you may find the slope. That's something that that's something which you can use the t-value. So again, this is the same p-value that we have here, and the F statistic. Well, the purpose of the F statistic is for the ANOVA table, and basically, like the result of the ANOVA table, or what you want to do with the ANOVA table is the same thing that you want to do with the model utility test. So if you want to find if some variable is significant or not. So we can generate the ANOVA table too for this regression model. So you're going to call the function ANOVA. And this is our ANOVA. But again, it's like the same result. So you may notice that we have actually the same p-value. So now that we already have that, let's going to make some plots. So you're going to plot the temperature and the consumption. And also I'm gonna have a line okay, so let's run it. Am I right? So this is the model This is the data set, and this is our regression line. Okay. We can, well, we know that we have like more than one feature in this problem. So we know, well, we were actually working with the consumption and the temperature, but also there's one more that is the weekly income of the families in the, and we want to see the relevant for the ice cream consumption. So let's gonna plot a 3D plot to see what is like what is the behavior of the three variables that we are considering here. So for doing that, I think that I already have the package. So let me for that. Yeah, I have the package. But if you don't have the package and you want to use it, remember that you can use the command install that package. And you can use this package for 3D plot visualization. Okay, so I'm not gonna run this line because I already have installed this package. But what I'm gonna do is to call it using function library. Okay. And I'm gonna do my 3D plot. This is the function that I'm gonna call plot 3D. I wanna see the income and to see also the temperature and the consumption. Okay, so you're gonna run it. And let me show you it appears in other. Okay, this is our 3D plot. So basically you can see that, yeah, we can notice that there's maybe like a correlation between the consumption, the temperature, and the ice cream. So this is why actually Anisha mentioned before that R is really amazing for data visualization, because you can actually do something like this and you can generate some animation also. Okay, so well, that's depending on the package too. What I recommend is like you can try to see what package you can use for plotting, see for data visualization. One that is very useful and one that people are actually starting to use a lot during these days is ggplot. So you can actually install that package in R, and you can try like see how you can perform. You can work with ggplot. So ggplot work with layers and it's something kind of similar. I don't know, guys, if you know what is RGIS. RGIS is like is well, it's a software for geographic data visualization, and the way that it works is it's with layers. So ggplot works in that way. So you can like create a plot with layers, and you can have like a really amazing plot if you practice with that. But that's like my recommendation for you. So you can like search online in the web about ggplot and how to use ggplot. Okay, so let's keep continuing with this example. Now what we want to do is to generate multivariate linear regression. So we're gonna call, we're gonna define this new variable regression 2, and I'm gonna storage this the multiple linear regression. So how we gonna do that as we did it before? Now I want to see now we can do this. Okay, we can try this. And also I want to see a summary of the multivariate linear regression. Okay, so the same thing. This is like the same structure of the summary of we see before for one for the simple linear regression. Now in this case we have two variables. So this is the estimation for the intersection and for the beta 1 and beta 2. Again, this is the standard error, the t-values, and also we have here the p-value. So in general, we can say like the weekly income and temperature. They are like significant variables in the linear model. But well, probably temperature is like more significant than income according to R. And the other thing that we can notice here is the R square. So it's actually a good R square. I think that in the practice, if you have something that is greater than 50%, that would be awesome. And that's what happened here. So we have a value of the R square, or the coefficient of determination, that is greater than that 0.5 at least. And we can also generate the ANOVA table for that one. And this is the ANOVA. So well, according to the ANOVA, actually the temperature is probably the only significant one, the only significant variable that we have to consider in the model. Maybe income is not like that significant because the p-value is actually too high in this case. So remember that the result of what you want to see with the ANOVA is the same thing that you want to see with the model utility test. So it's basically an hypothesis test when you want to find is the slope variable, is the slope value is equal to 0. There is a probability that the value is equal to 0. So if we refuse that idea, if we refuse that hypothesis, so that's what happened here. Okay. And we can make a comparison between both regressions too. So we can generate an ANOVA with regression 1 and regression 2. Okay, so let's keep continue with this, and do some of the posterior analysis. So you're gonna plot the consumption versus the regression to residuals. Okay, so we can notice like well, the residuals they have like some yeah, I mean that probably we can see like they are kind of they have some kind of random behavior, and that will be fine. But the problem is that we have some layers over, maybe there is some trend. So probably we should be like very careful with this model. But in general, we can notice that actually image works good. And we can also generate a plane. So let's do that. So, so for doing that, or for generate our plane, what I'm gonna do is I'm gonna call another package. So the name of this package, in case that you want to install it, so you can use Shock for generate 3D planes. I'm gonna call it from my library. So this is the black color. Right? And this is our plane. So this is the plane. The plane is the regression model, and all the points that you can see here are the points from the data set. This is like kind of the similar chart that we have, or scatter plot that we have from the beginning when we were, like we were seeing what was the way that the linear model behaved against the data. So those are some things very nice that we can do with R2. Okay, so do you have any question about this? Is that makes sense to you? There's something that you want me to go over? Okay, so let's going to continue with we're going to keep continue with this. So I'm gonna save this, because what I'm gonna do is to create a new file, a new R script here, and I'm gonna set the same directory as well, because in this folder, as I told you at the beginning, I have all the, yes? Oh, I have a question. Yes, we will send you, we will share to all of you guys the recording of the session. So that's why we actually are recording the session. Okay. So what we're gonna do now? So now we have this mod. We already do the solve with the ice cream. So let's going to work with another example. So this is the Titanic problem. So with this problem, what we're gonna do, a few more things. So the first thing is to see the data that we have. Then we are going to categorize, or we are going to check how we can work with categorical data and how we can work with continuous variables. And the objective is to create a classification model. So what is the classification model that we are going to use is the logistic regression. So this is the general structure, or the general, well, this is like the formal logistic regression model. And this is the one that we're going to use for make the classification based on our data sets. So let's take a look of the data set. So these are all the variables that we have. We have passenger. We want to know if this passenger they survive or not. So survive gonna be our response variable. So then we have P class, the name, the sex, age. We have this variable CSP, parts, ticket, fare, cabin, and market. And this is our data set. The first thing that you may notice here is that there are some missing values. So for example, in this row, you may notice that we don't have the information of the age from this particular person. Probably that's something that also happens over here with the others column or with the other variable. So that's something in which we have to work. We want to work in which how to identify the missing values and how we can remove them of our data set. So let's work on that. So the first thing that I'm gonna do is to remove is, well, besides setting our working directory, I'm gonna remove sorry. I'm gonna remove all the elements in my environment. So for doing that, this is like the, well, probably is the complicated way. You remember that you can always use you can click on this button. And also I want to clean this. All right. So the next thing that I want to do is to create a variable that I'm going to call it training. Yeah, training data. And training data, well, training data row, because the data is not clean so far. So we are going to storage our data set, the data set that I just showed you. And remember that I also emailed you the file. So as we did it before, I'm going to use the function appdata frame. And inside that one, I'm going to use the function create CSV, the file, and we want to keep the headers. So this is not necessary because headers, they are true by default. And then we have the non strings. Okay, so we are going to assign a non value for everything that is actually blank, that is missing. Okay, so let's view our data here in R. So let's see what is the dimension, how many observations we have in the data set. So I'm gonna use this function dimensions. So we have 12 variables and 891 observations. And this is also a nice function that I'm gonna show you. So with this function, we can create a matrix of the scatter plots. So let me show you how it works. Okay. All right, so we got it. Yeah, it takes some time because there are a lot of scatter plots. So what are you actually looking at here? In the exercise 1, okay, let me go back there. This one, we were doing, what we did here was to remove the first column of the dataset. That's what we did here. This is the first one. So when you have the minus, it's because we want to remove it. Okay. So bring back here. So this is basically all the possible combination of scatter plots that we may have from this data set. So remember that we have 12 features or 12 variables, and that's why we have a 12 by 12 matrix. And this can actually give us like an idea how variables or how the variables can be correlated. For example, you may notice that here there's no like too much correlation between these variables, or maybe over here as well. So that's something like we can actually notice. So if you want to, like, instead of creating one scatter plot for each one of the combination, we have a nice command or a nice function that allows us to see all the scatter for all the possible combination of variables in the dataset. I have one more question here. -1. In the line 7 is -1. So the meaning of that is that we want to remove, again, we want to remove the first column of the dataset. Okay, so let's keep continuing with this. Now something that could be actually very nice and besides important in our analysis is to see the levels of the data. So I'm gonna use this function supply. Supply is a function, it's a variation of a function that is called, well, lapply. So it's kind of a variation of this function. The only difference between this one and this one is the way in which they show the results. So for example, I think that Sapli is like a more user friendly than Laply, because what that's over here is like a create or L applied. What actually does is to create a list of a list depending of some data set that we already have defining before in R. So we can do the same thing with edge apply, but actually in a nicer way. So let me show you. I have training here. We have function. And here we have the length. Sorry. And we want to see all the unique values of x. So what is x? X is like a temporal variable for storing our training data row variable. And if you want to know more information about well, you can about supply, you can always type this. Although I would be better doing that in there. So you see, it's a user-friendly version and wrapper of Laplace. So lapply returns a list of the same length as S. So where F basically in this case S is a data set. So let's run it, and you may see what happened. So here we have all our variables or our columns in the data set and all the information in that data set. So we know that we have, well, at least in the column passenger ID, we have 891 observation. So there are 891 different observations. So they are basically, if you want to see them as numbers, they are two numbers. So for survive, the levels, they are only two levels. So it's 1 or 0. So survived or not survived. Then we have the PC class, we have the name, we have the sets, and that actually have two levels, male and female. We have the ages, they have 89 levels. The CIBSP variable, parts, ticket, fare, and coming. So that's what is levels. So levels are basically the values that may take, or according to the data set, that may take our variables. So let's start with the cleaning. So there are different ways to do the cleaning. I'm going to show you like one way to do that. So first, let's going to check all the missing values. Instead of seeing the length, what I want to see is there is some value. So here we have two. In cabin we have 687 missing values. And we have in the age 177 missing values. And well, that's a lot of missing values that we have there. One to do that if you want to check all the missing values. You can install the package Amelia. So I'm gonna see if I have it. Yeah, I have it. Okay. So you can install the package, capital A. And use the following function: mismap training data row. So this function is gonna return you like a lot of missing values. I'm sorry, I forgot to call the package. No. So this is the result of the Amelia. So for example, we can notice here in the cabin, actually, there are a lot of missing values. The same thing happened with age, and with embark, we have only two missing values. So how we can deal with the ONA or NAS or missing values? I'm sorry. So we know that cabin have too many missing values, right? So we should drop it. And probably we have to do the same thing with name and ID, because they are not like they are not going to use variables that we can use for as a predictors. So we also have to remove ID and name. So I'm going to create this variable data, and data will be a subset of the training data row. And from there, we are going to select the following array of columns. So we want to see column number 2, that is the passenger survive or not. Column number 3, we want to get rid of the name and the passenger ID, and also, well, this one is the first one. This one is number 4, and cabin is the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yeah, of course, it was 11. So I want to see 3, 5, 6, 7, 8, 9, 10, and 12. And now let's going to call again the mismap. Okay, so now we have only age, embark, fare, ticket, part, SIP, SIP, SP, sets, P class, and survive. So now we have to deal with all the missing values, the age and the embark. So since there are only two values in the embark, well, I think that only one. Let me check again. No, two. There are two. Two missing values. We can remove those rows out of the data. So the following lines are for getting rid of the mark missing values. Data. So remember, in this way, we are selecting all values that are not NA because we are using the exclamation symbol. Exclamation symbol in R is for negations. So this is like the opposite of the function. So what gonna do R or what's gonna do R is actually the opposite that this function actually does. That is identify all the missing values, or is to tell if some value is missing or not. And we can try again the mismatch. Okay, so let's run this. And I think that you can see there that there's no any missing values for the bar. So now we have to manage all the missing values of age. So we can do two things. We can remove all the values or all the NA values from all the rows with NAs. So for example, we can do this. I'm gonna do this because I don't want to mess with the data. So this is like temporal data. But this is something that we can do. We can call the function NA or NAT meet data. And now we can see that there's no any missing values now. So all so the rate actually is equal to 100%. So we know the information from all the variables here, but there's probably okay. So sorry for that. But let's going to see what happened with that data set. So now we have like 700 712 observation and 9 variables. That's one way, but probably, I mean, that's depend of the amount of data that you have. So if you have like a plenty of data and you can remove the rows, that will be fine. But Otherwise, I mean, that will be like kind of complicated if you need like if your data set is too small and there are some missing values. There should be some way in which you can manage that, or you can handle with those missing values, and that's the other way that we're gonna check here. But this is probably very useful. Again, this probably will be very useful in case that you have plenty of data. So you have a lot of data and you can remove the row without any problem. But if you don't have like that many rows, you can use the following approach. So we call this imputation with the mean. The mean, the median, or the mode. And the idea here is to replace the missing values the mean or the median or the mode. So for this problem or for this example, we are going to use the mean. So data age sorry. So all the missing values in the column age, they will be equal to the mean of the values in the column age. And again, we have 100% of the observations. We're going to check the dimension of that data set. So well, as I told you before, we keep like we keep more data. So this is better in case that you don't have like a lot of data, and probably this is like the best for handle that situation. Now let's going to check all the variables that we have. So it's important to know that there are some categorical variables in the dataset. We know that because, well, we just take a really quick view of the dataset. But in this case, for example, I can notice that the variable sex is a categorical variable, right? Or probably is a categorical variable. So what we're gonna do is to check if what are the categorical variables in the dataset. So call names. Those are all the call names. So is that factor so class and so on. Just gonna copy and paste this along. All right. So I'm gonna run it. and you can notice that. So for example, survive is not a factor. So factor is, well, is the way in which we call categorical data in R. So in this case, for example, survive is not a factor. Bad sets is a factor, and also embark is a factor. We can also do that actually very quickly if we use summary data, and we can notice that, for example, you can notice what happened with sets and what happened with embark. So they are categorical variables. So since they are categorical variables, that means that, for example, instead of working only with the variable sets, we need to work with the variable female and the variable male, and they will, yeah, we need to transform them into binary values. So if the passenger is a female, so that's going to be equals 1. It's not, that will be equal to 0. And the same thing happened with embark, but probably because this, we can use 0 and 1, we don't need this. But embark, for example, have 3 labels, and that means that this one will be like a little bit more complicated to handle than sets. So perhaps the dummy coding, that's the way we call it, to transform a categorical variable into several binary variables. It's not necessary for sets because there are only 2 values there, but it's not the same thing with embark. We have 3 labels for that variable here. We can also use the function contrast to get more information about about the way in which are actually gonna actually are gonna is going to, I'm sorry, is going to decode the categorical value. So let's going to use the contrast function. What's the problem? Okay, it happened with the male and female, so this is fine. And for the case of the embark, so this is what I tell you before, guys. So you're gonna use as a baseline the male. So it is not a male. That means that the passenger was a female, and that is equal to 0. And it is a male. That's the are gonna use for that case. And the same thing happened here. We have C, Q, S. So you're gonna use 0 and 0 when Q and H they are equal to 0. When both then they are equal to 0, that means that is a C. So when Q is equal to 1 and S is equal to 0, that's a Q. And when Q is equal to 0 and S is equal to 1, that's an S. So that's the way in which R is going to work with those categorical variables. So I'm going to try to move a little bit quickly here. or it's very important to remove or to reset the rows. So, and the reason is because probably we may find trouble trying to run some internal loop in some function. So in order to do that, let me type some comment here. So we know that it's important to reset rows. Or so again, this is very important to get the internal loops working perfectly or working. Ay, Dios mío. Okay, before continue with our classification model, because we are basically finished all the cleaning, it's important to reset the rows. So we have to do this because otherwise we probably gonna find some problems trying to run some internal functions or some internal loops in some function that we are gonna use for the classification model. So the best way to do that is by using the function row names. And I'm gonna tell to the function row names that all the rows in the data set will be reset. So this is the way to do it. Okay, so now let's going to see what is the final structure of our clean data set. So all right, so we have the following variables. We have survive, that one is what that one is our response variable. Then we have the passenger class, we have the sex, the age, the tip XP, parts, ticket, fare, and embark. Right now that I notices, we may have some problems trying to run in the classification problem if we keep variable or the column ticket. And the reason is because of the type of variable. So if you take a look at that, you may notice that there are some characters and numbers there. So probably probably not. Actually, this is something that is totally certain, is that R is going to recognize the column ticket as the variable ticket as a categorical value. And the problem with that is that it may have too many levels that is going to be complicated for our model to try to but it won't be complicated for R to process the that quantity of categorical variables, but what is going to be hard, or what is going to be like a real mess for us, is that this is not going to give us like a real information or real insight about the way in which the survive variable is going to behave, because ticket is like, you know, like the initial variable that we have as an ID and name. So they are not going to be, ticket is not like very relevant for our analysis. So what I'm going to do now is to get rid of that column. So we can do that. I'm just going to go back here. And from this point, let me check here. So in this line, the line number 28, we define what is going to be the size and the columns or variables for the dataset. That is basically a subset of the training data row. So I just gonna run again. I just want to see again the structure of the training data row, just to see what is the ID of the column ticket. Right, so this is column number 1. This is 2, 3, 4, 5, 6, 7, 8, 9. So this column is column number 9. So that's the one that we want to get rid of. So I just gonna delete this. And now, well, we don't need this line of code anymore. I'm gonna close this again and again. And well, what I'm gonna do is like running almost everything. So we can like run every day for data. So I'm gonna do this. Also this one. And also I want to see everything from this point. Okay, definition of data, the summary of data. So here in the summary, you can see that we don't consider the tickets column here. All right, so I think that now the dataset is fine. So there's no more any cleaning that we have to perform. So now we can start with our classification model. So also we can see before doing that, we can see what is the final structure of the dataset again. So yes, this is like the best shape of the dataset. So everything's clean now. We don't have any missing values, and we don't have like some variables that may be like a mess for us. All right. Also, I just want to check what is the dimension of the data again. So yes, we have 889 observation, and we have 8 variables. So that's it. So let's keep continuing with this. So now we are going to feed the model. Right. So it's important in this point also to split the data for training and testing. So we are going to have like 2 sets now. We are going to have a training set, that is the one that we are going to use for fitting our classification model, and the second one is going to be the test set. That this one is the one that we are going to use, or is a portion of the whole data set that we are going to use to validate or to assess the performance of our classification model. So let's do that. So I'm going to set a random seed here, because we are going to use the sample function. So the train set. So for the train set, I'm going to create this variable train, and train is going to storage some part of the data set. And inside that, I'm going to call the sample. So sample, and inside sample, we have in rows of data. Okay, and comma. So what we are doing here, so basically here we are making a sample of all the rows of the clean data. So here we have like n rows, so that means that we have 889 rows, and from those 889 rows we are going to take a random sample of 800 rows, and that random sample of 800 rows, it will be our training set. Now let's going to define the test set. So this is training set. And this one is the testing set. Okay, so for the testing set, what we are going to do is to consider all the rows that are not in the train set. So to do that, this is the best way. Okay, so we are calling all the numbers that are not in the row names of the train set. So that's our test set, right? So do now. Let's do now our classification model. So for doing that, I'm gonna create this variable model in which I'm going to store all the information about the classification. So I'm gonna call the function general linear model, that is GLM, and I want to make predictions about survive. So that means that survive, as I mentioned before, is the response variable. We also want to consider all the features here, and family, we are going to use binomial distribution, and our link function is, and the data that we want to use is the train data or training set data. All right. So I'm gonna run this part. Let me run all this. Okay, so you see that everything is working. So now I'm gonna use the function summary to see what is the summary of our classification model. And this is basically our regression, so our logistic regression. So here we have the residuals, and here also we have our coefficients. So those are the coefficients for each one of the variables. So you may notice also what are relevance or significant variables in the model. So in this case, we have that each class is relevant. The sets, well, if the passenger is if male or not, that will be also relevant. So the sets is also a relevant variable. Remember that sets is a categorical variable and the baseline is male. So we want to, the model actually is making or is identifying if some passenger is a female or not, depending on if it's a male or not. Okay, so we have age that is also relevant or significant for our model, and we can also, well, what happened with SIP-SP, like probably it's not that relevant as the other variables, but we can keep it. There won't be any problem if we keep it. So we probably wanted to include it, to include this variable in our final model in order to reduce the residuals. So I'm just gonna type that comment over here. Sorry. So So let's gonna keep that. So now, another way to test what is like, well, one way to test what is the performance of our model is by using the R-square, right? So let's do that. Let's try to calculate or estimate the R-square for the classification model. So for doing that, we're gonna need to install a package. I think I already have it. Let me check that. But I'm gonna just type the line for you guys. This is the package that we are gonna use. PSCL. And here, let's see. Let me check. All right, I already have the package. So I'm gonna call that package. And from that package, I'm gonna use the function PR2 for our classification model. So this is actually give us like an idea of what is our R squared. So it's not like a really like well, for classification model it's kind of hard to try to get what is something similar to the R square that we use for the linear regression models. But in this case, we can see like what is the performance of the variable. So probably they are not like a really good indicators. But let's going to continue with this. Let's going to see how good is the model in predicting from the test. So now I'm gonna create a variable fitted results. And I'm gonna call the function predict. So with the function predict, we can generate prediction. We can generate some prediction from a model. So I'm gonna use our classification model in this case, and I also gonna create a new data here. New data variable. New data variable will be a subset of the test set. Okay, so why we couldn't use the whole test set? Because remember, guys, that the test set, well, in the test set, we have the first column that is survived. So we for this part of, or in this point, we only need to consider all the not the response variables, but just the variables, just the predictor variables. So I'm gonna call all of them. That will be 2, 3, 4, 5, 6, 7, and 8. And that response. Okay, so you're gonna run it. So everything seems fine now. I'm gonna update some values for results. This function if else actually is very useful. So what I'm gonna do here is just make a classification. So we already know that fitted results are the result of our predictions, right? So what we are gonna do now is just transform those results into into a binary variable. So how we can do that? Well, so remember that the result of the logistic regression is a probability. So what we want to do is just that probability into a 1 or a 0, a binary variable or a binary outcome. Sorry. So in order to do that, so I'm gonna take all the results from our prediction. I'm gonna compare with 0.5. So if some value is greater than 0.5, so we want that the outcome be 1. Otherwise, we want that the outcome transform into 0. So this is just for transform predictions into a binary responses or outcomes, right? Okay, so let me run this line. So it seems that I have some, yes, I have a typo here. Okay, so everything is working. Now I'm gonna create a new variable that is gonna call it, I'm gonna call this variable misclassification error. And this one will be the mean of the fitted results. And we also want to make this comparison. So in general, what are we doing here is to, well, basically we have this array of data and we also have this array. So we are just making a comparison between both arrays between the both arrays, and well, we are making this comparison, and if they are not like the same values, so if they are not the same results, so we are going to consider that in the mean. So that's gonna give like like a true. So the result of this logical operation is true or false. So each time that we have a true, we are going to consider that in the mean, and we are going to get like an estimation of how many times our prediction was wrong. So this is gonna give like an idea of how many times our was not correct or was not accurate or was, as I mentioned before, wrong. So let's go into that line. And now what I want to see is just the accuracy of our model. So I'm gonna do this. So I'm gonna print the results. I'm gonna make this a string with accuracy will be equal to 1 minus misclassification error. All right. So and this is the accuracy of our model. So that's mean like 75% of the time we are making like a really good prediction we are getting a good prediction of the response variable, right? So finally, it's just as a part of a complementary analysis, we can create the confusion matrix. Okay, so with that, we're gonna create a table. With the results. says survive. Okay, so these are basically the times that we have a really a good prediction here. So 46, and so out of, well, the meaning of this is like, for example, we have this is the filter results 0 and 1, and we also have the actual value of the responses. So basically, what we want to in which we want to focus is in the true prediction. So what are the true predictions? The diagonal in this matrix. So we have like 46 times. 46 times we have like we found that there is a 0 in our survive variable, and 40 times we got a good prediction of that variable. And the same thing happened with number 1. So when the survive variable is equal to 1, in 23 times we get like a good prediction of that one. So that's the way in which we can use the confusion matrix. So that's everything for today, guys. Thank you to all the attendees for your attendance today, and please stay tuned for the following session in our data bootcamp. Thank you.